That's awesome, Douwe. Thank you so much for joining. You didn't only Percy got to hear my embarrassing fact, which is we do this exercise whenever someone new joins the company. We say, "What would your like totally orthogonal career be?" And mine was, which I mean more than half seriously. A lot of people don't believe this is like a creative marketing role at Taco Bell. Like whoever gets to decide, what new kind of weird candies or whatever they shove into a quesadilla. I just think that would be fun. But a little bit odd. Either way, Douwe, thank you so much for joining. And just to add on to the introduction, Douwe has a long career in both, applications in the field, like with the startup he's running right now, taking LLMs and AI to the enterprise, but also he's an adjunct professor at Stanford. He was previously head of research at Hugging Face and a research scientist at Facebook AI Research, and has done tons of seminal work, including work on evaluation, which we were just talking about with Percy, via projects like Dynabench, and work on some topics that are now all the rage, like retrieval augmented generation, where he was was writing the seminal paper on that, or wrote, sorry. So evaluation could be fun to talk about, but maybe I'll start there. So you were one of the lead authors of the original RAG paper, where you coined the term. What do you think people get right about RAG today, and what do you think people get wrong about it today, now that it's kind of a household term, at least in the AI world?
It's very interesting, actually. So what people call RAG now is kind of a baseline almost in the original RAG paper. So I don't think at the time we would have even been able to write a paper just about vector database plus language model. I think it would have been rejected. So the paper is really about how can we have these two separate sources of data, or these two separate models, an embedding model that you use for retrieval, and a generative model that you use for, so a language model basically for generating answers in like open domain question answering settings. The paper is about how can we learn to do the retrieval so that you find things that are relevant for the language model that consumes the things you retrieve, essentially. So in table 6, for anyone who's interested in looking at the actual paper, we show that if you fine-tune this system, so if you do actually learn at least the query embedding, then you do much, much better than the frozen RAG that everybody is using right now. So I think that's kind of an encouraging thing, right? So what everybody's doing right now already seems to work quite well, and we know for a fact that you can do even better.
I agree that with that optimistic take on it, and actually we were just talking with Percy previously about the general view that kind of along with the choice of foundation model, that these are foundations. There's usually some house building on top, some customization, fine tuning, etc. And yeah, I found it very interesting that in the paper, because when everyone started getting excited about RAG again and using it, as a verb, RAG it, I went back to the paper and to your point, there were actually there were two uses of fine tuning of both the retrieval model and the LLM itself. And it's interesting, even in the Q&A, I saw one come up, and looking forward to discussing it in the Q&A session later. But about, should I use RAG or fine tuning or prompting? And I know you and I have talked before. I increasingly kind of think those are really complementary tools that unified more. I mean, in your paper, you did both fine tuning and RAG together. So I think it's a nice exemplar of that. How are you seeing people kind of navigating this emerging tool set? When you consider RAG and fine tuning and prompting.
Yeah, so I always tell people. And it probably doesn't feel that way, but it's still very early days, right? So we're still figuring a lot of this out. My bet would be on some sort of hybrid between retrieval augmentation on the one hand, when you need it to generalize to your own data, but then probably some fine tuning, not necessarily on your own company data, because I think you can cover most of that with retrieval augmentation. But I do think that you want to fine tune the end-to-end model. So not just the language model, but the whole thing on the use case that you want to use this for, right? So then you can learn what sort of retrieval you want to do for solving the use case, and how you want the language model to deal with the things you retrieved. And then prompting obviously plays a very important role in this too. Although I guess ideally it shouldn't play any role, because these models, they should be very robust to different prompts. But yeah, I mean, as Percy also points out with a lot of his evaluation work, like these things are still very brittle. So that's just something that we have to improve across the board.
Yeah, it's a good point. I've heard others make this, saying like, look, the advent of prompt engineering and all the kind of novel and sometimes hilarious strategies for prompting are really a sign of the lack of robustness or the failure of robustness and stability of current models.
Absolutely. And people also like, so one big issue I have with prompt engineering these days is that so we have all of these practices in academic machine learning around having held out test sets and validation sets, and you're not supposed to like tune your model on the test set, right? That's one of the golden rules. Everybody knows that. It seems like the new generation is less familiar with that separation. And a lot of folks are really tuning prompts directly on the test set, saying, okay, this works, then deploying it in production, and they're finding out that their test set was actually a dev set and it doesn't generalize to their real data. So that's a big problem.
Yeah, there's a fine line. I actually think it's quite interesting, and this will lead into maybe some discussion on evaluation in a second, but I think we swing between two extremes. On the one hand, I feel like we've taught by accident a generation of data scientists to kind of never look at the test set, right? Because we've taught them, don't cheat on the don't cheat on the answer key, right? So then people interpret that as just don't look or think about the evaluation data set, and consequently, we're now quite impoverished in terms of our, or we're quite behind in terms of maturity of evaluation and testing and tested engineering in general. But on the other hand, you can swing to the other extreme where you do more than look at the test set. You literally, as you said, like develop and tune your prompts on it, which is, that is, not, I don't mean maybe morally, but that's cheating, right? That's not going to lead to good, robust generalization. So there's some there's a middle ground that we have to chart as a community, or really the right point. But quickly on the before we move to evaluation, on the the RAG versus fine tuning point, that's very similar to what we're seeing, for what it's worth, with enterprise customers and with some of our academic work, is that when you get to a specific use case or a specific kind of something measurable that you're trying to improve, that's when you get into the fine tuning. And I mean, I haven't shared this with you before, so I'd be very interested to know if you like or dislike this metaphor as the original RAG paper author. But I think of out of the box LLM is kind of like a med student, and just as an example, right? So, and you're trying to get the student to make a specialty diagnosis in, say, oncology, right? You can try several approaches there. You could try giving the med student very careful instructions, and for some simpler tasks, taking basic vitals or measurements, you can probably accomplish that. That's kind of like prompting. Some things you're going to need lots of training. That's why med students go to specialty school. That's like fine tuning. And then in some cases, even the most the optimal Oracle expert oncologist still needs to pull up the patient's chart and or maybe relevant literature from the academic literature. And so to me, that kind of is a simple, and that's RAG, right? And that's at least pulling in external information. To me, that's kind of a simple metaphor for how these are complementary techniques, not competitive or alternative, and they're kind of on a spectrum as you try different and harder tasks.
Absolutely, yeah. I think that's a perfect metaphor for this. So yeah, humans, you learn a lot of general stuff through self-supervised learning by just experiencing the world. Then you go to university, you really specialize, you do your fine-tuning, but you're still, when you take a lot of these very difficult exams, they're open book exams, right? You get access to the book. And when you do your job, you can always go back to the book, or you can go to the internet and ask questions. And so it's not like you have to cram all of this knowledge into your parameters. You have access to extraneous sources of information. So that's why it's just a very natural paradigm, I think. And one interesting point maybe to point out is that this idea of long context transformers, long context language models, the way we make those work is through sparse attention mechanisms. So the sparsity basically says we're going to discard whole chunks in our context window and only focus on the things that really matter. And so this sparsity is very similar to the non-parametric version that you do with a retrieval model. And so long context windows, they feel sort of inefficient because you have a lot of information there that you don't really need. So if you take long context windows to the extreme, then you end up with a non-parametric retriever model. So it's all on the
I really like that. Yeah, I really like that connection. I hadn't thought about that before. And if you it also highlights the kind of the transparency or lineage trade-off as well, because the as you said, like the weighting of that sparsity pattern over the long context is kind of like what you're retrieving, but it's a lot more opaque than when you're actually modularizing, decoupling the retrieval model. You can see what actual chunks of the long context from my vector database or whatever I actually retrieved.
That's
Right?
exactly it. So if you do it non-parametrically, like with a RAG model or a retrieval augmented language model, then you get attribution guarantee. So you can actually point back and say, like, it comes from here. I have this much confidence that I actually use this thing. So that allows you to solve hallucination. We have papers from like 2020 where we showed that these models hallucinate less than regular parametric models. So yeah, it's just a better architecture. But obviously, I'm very biased.
Yeah, but I mean, to the point that we both just echoed, it's not an either or. A lot of this stuff is going to come together, and I actually think one thing that we're not yet thinking about enough is, I think it's a more interesting trade-off space. A lot of us, ourselves included, when we go and we try to get things to work with customers or support of their platform, thinking very much about accuracy, which is the first thing that you should be thinking about. And we'll get into in a second. I have some questions on evaluation. We're not there yet, right? We have got a lot of work to do to even get that right, but eventually, as you move, like we talked about this with Percy too, you go from the first mile kind of exploration to actual system deployment. You have a richer trade-off space. You have to think about latency and cost and size and attribution, and there are interesting, rich trade-offs across all of those, right? Sometimes memorizing things parametrically can be advantageous, and sometimes it can be a severe drawback depending on how much you care about all of those different axes. So I think it's going to be super interesting to navigate, and I don't think it's rocket science, but I think there's a lot of maturity that we need to kind of go through.
But it's also a good sign, right? So I think where we are right now in the field is that there's been this kind of demo disease, as we call it at Contextual, right? Everybody wants to build a cool demo. You can do that right now with one of these frozen RAG systems. At Contextual, we call those Frankenstein's monster. You're kind of coupling things together, and it's sort of like, it can walk, but not really. It doesn't really have a soul. So where we're going next is really to like production deployments, and we're starting to see real production deployments in real enterprises, but it's moving a lot slower than a lot of people, I think, would have predicted. And a big factor in that is evaluation, actually. Right? So really understanding the risks of a deployment, going beyond just accuracy on some held out test set that somebody might have tuned a prompt on, and going to a real robust system that you can expose to your customers or to your internal employees without worrying about things going disastrously wrong.
So let's jump into that for a few minutes. Because I also want to ask you about your experiences of making the transition, if we have time, from kind of academic and research world to startup to working in the enterprise. But first on evaluation. So you've done some exciting work there. Dynabench is an example. At a high level, what do you think? What are the most kind of salient things that are missing when you're trying to evaluate? And let's focus on the enterprise. You're trying to evaluate how an LLM or a foundation model system is doing. Where do current benchmarks and evaluation methods fall short?
Yeah, so I think I'm a big fan of the Helm project and Percy's work in general there. So I think the first thing you need to do is think about it much more holistically. So it's not just about accuracy, and it's definitely not just about one test set. It's about many test sets, and then there are lots of different things you can care about. So you mentioned latency, but there's fairness, robustness, all kinds of other, like, is it actually using your company's tone? Are there any legal risks that we're exposing ourselves to? Like, are we allowed to talk about our own company stock when somebody asks us? Right. So a Google or Meta, they have to be very careful, I think, with what their language model says about their own stock. Right. So those are the kinds of things that if you're an academic, you don't really think about. But these are really make or break things for big enterprises.
Agreed. So I guess, since I think we're almost at time, let me ask a little bit about, similar to some of the Snorkel team, there was this, you make this transition, from, I think of it, academic, and not to bias the answer, but from our perspective, it's kind of like you're switching different modes, different phases of a project. There's certain things that academia and the research world it's the best place to do. And then there's certain things where you can't do it unless you actually, build a team that has different skill sets to productize, to get out there and deploy with real enterprises, real settings. What have been some of the lessons so far in making that transition and starting Contextual?
Yeah, this is a fascinating question. I think so. Obviously, I got this question beforehand, so I had some time to think about it. And when I was thinking about it, I wasn't really sure. So one way to think about it is actually that they're very similar. If you're very good at being an academic, then you have to also be very good at branding and marketing and kind of the product work almost around like having a very polished paper and things like that, right? So you need to have a solid core, a good research finding, but then if you want to be a really successful academic, then you need to do a lot of the same things that you need to do if you're in a startup. So I thought that was quite an interesting observation because the other thing, and maybe that's more specific to like AI and language model startups.
And by the way, just for what it's worth, I agree with that. I mean, a little biased over here as well, but like I think and because sometimes you get kind of people think that's suspect, but I think it is. I think the distinction, I'd love to hear if you agree with this, is that a lot of the core skills are very, very similar. A lot of the metrics and objectives are obviously different, right? So, having to be a kind of one person shop for every, having to understand how important marketing and messaging and branding and packaging is, having to productize, having to get feedback from users, at least if you do a certain brand of, research that's applied enough, that's a very, it's a skill set that is easily shapeable into what you need for startups. The metrics are very different, right? When you're running a business and you're serving customers, you don't care as much about novelty, right? You don't care as much about certain other things as well.
Yeah, but it's the same thing, right? So like if you build something awesome, or if you have an awesome research finding but you present it in the wrong way, then nobody's going to care. And so it's exactly the same with a startup. And the other thing I think is like failing fast is actually something you want to do in startups, and you also want to do in academia. And so you should basically be ready to discard most of your ideas as bad ideas. That's where good ideas come from. So I think those are pretty similar too. Yeah.
I love that point as well. So I guess we're almost gonna be at time. I'm gonna wait till whenever Rebecca shows up. She's the hook, the Grim Reaper. That means our time is done. But we have a few minutes more because I don't see her yet. So maybe last quick question. What do you think one of the answers, at least from my perspective, and I would guess from yours, is evaluation, but like, what are some of the challenges in the enterprise that you think the academic kind of open source community underestimates with respect to AI that you're running into? And again, as you can imagine, I have my own thoughts here. I know we've traded notes on this before, but just for the audience here, like what was surprising there for you as you entered kind of transitioned?
Yeah, so you're right that I would say evaluation there. I mean, and so I still think the field is in a complete like evaluation crisis. And so Helm is trying to do something about that. I think Dynabench is even more extreme and experimental, where we basically have like dynamic leaderboards. So there isn't really a static ranking anymore, and we have this dynamic approach to models kind of continuously updating, and then people trying to break these models. So tying into that point, I think what's really missing in academia is systems thinking. And and that's kind of by design sometimes, but right now we're getting to a point where you can evaluate either the language model itself in a very isolated setting, or you can evaluate the whole system that is built around that language model. And those are very, very different things, and you cannot compare them, right? So when you are calling the GPT-4 API, that's a system, that's not a model. There's a lot of stuff going on there, right? And there's like safety filters on top and like other things that we don't know what's actually going on inside that system. It's just a black box. And so if you compare that to just a bare bones model, maybe that doesn't even have any like reinforcement learning from human feedback, no fine tuning. That's just not even a comparison you want to make, right? I think in academia, and this is going to require a lot of standardization, I think, around what these systems look like. But if we can figure that out, then we can start thinking much more holistically, again, about what we're doing with these powerful things.
I think it makes a lot of sense. And by the way, I was wrong on timing. Apparently, we have until 9:50.
Oh, nice.
we actually have a lot more time, so we'll go off script and have and we have some time to go. So I mean, I think that's such a good point, and that gets to your work on Dynabench about just I think it's kind of two axes at least. One is thinking about a system versus one module of a system, right? Which is always tougher to I mean, the full systems take longer to build and they take longer to do research on as well. And I think academia and the research world has actually a quite long and fruitful history of systems research, but it always is a lot slower than, hey, I came up with a new algorithm, right? And and it often it takes a little bit longer for the systems work to be appreciated, but we do need to focus there. And then there's a kind of evaluation that's more dynamic and holistic. Makes me think of when I was younger, like in middle school, I took like 100 basketball shots every day by myself, and I thought that would make me good at playing basketball. And surprise, surprise, it did not. Because, I think of that as like, okay, like one target task in isolation versus a real dynamic system, a little bit different, right?
Yeah. So actually, one point. So since we have a bit more time, like something that really ties in nicely, I think, around like evaluation and systems, is data. And so, as everybody at Snorkel knows, but I think a lot of people in this call also need to know, at least, data is really the real gold here. So like the architecture is sort of generalized. Everybody uses the same kind of thing with a couple of tweaks. Compute is a scarce resource, but that's going to become less scarce over time. So it really is all about the data. And I think maybe this is starting to change now, but for a long time, actually, both in industry and in academia, people have not had enough respect for data and how important it is and how much you can actually gain from thinking about the data. And so doing like weekly supervised learning or trying to understand your weaknesses, trying to patch up those weaknesses, you can close like the additional 10% that you really need to get to a production deployment from your Qt demo.
Yeah, and I mean, that is you're definitely speaking to the preaching to the Snorkel choir here. And for those that are new to what we work on here at Snorkel, both at the company and then back at Stanford and at UW, all about how you label and develop the data more like more programmatically, more software development like to tune or customize models. As a side note, or actually a lot more than a side note, you need evaluation to be properly mature to really do that, right? And I think that's one thing that people misunderstand is people are starting to realize, and this has happened before, that data is important, right? The original paper that coined the term large language model was, I think, a 2007 Google paper where they used an algorithm called stupid backoff, which I still think is one of the funniest trolls of all time in academic papers. Like all these fancy, French names for algorithms for the decoding stage of the language model, because language models have existed since the 80s and 90s, and they used an algorithm called stupid backoff, but they used 100x the amount of data, something like that. They blew them all away. So everyone kind of understands like more data and better data, garbage in, garbage out. You need good quality data. But I think what folks generally underestimate is that, or just misunderstand, is that it's not just generically good data. You need data that's labeled and curated for your use case. That goes back to what you said, right? It's not just about cleaning data. It's about curating it and labeling it and developing it for a specific use case, for a specific evaluation target. And you can't know where you need to do that development if you don't have evaluation in place to tell you where the model or the system is falling down. So I think evaluation maturity and how fine-grained your evaluation is goes hand in hand with how efficient and successful you can be at the data curation and development.
Exactly. Yeah, you need to know what you're hill climbing on, right? So we're optimizing all of these systems. Big end-to-end neural networks basically don't really have an idea what's going on inside the neural network. So we need to be able to measure the impact of our data on our downstream performance. So yeah, it's all like a system, and it's all one big loop that's driven by data.
Yeah, I think it comes back to that. And I think about like a really simple sandwich model. Like you've got data coming in, you've got data and all the knowledge to curate that data, right? And that data comes in through various ports, through retrieval augmented generation, through fine-tuning, through pre-training, through in-context learning, that's more ad hoc, like prompt engineering. And then on the output side, you've got how you deploy the model. What is the UI UX? What's the deployment mode? What's the what's the business process or user experience that it plugs into? I think the inputs and outputs are where naturally all the diversity of the action is at. A lot of the model and algorithm and compute layers is gonna, is already a lot more standardized, and going to continue to get that way.
For sure.
It's kind of one way I think about it. But yeah, so I think, I mean, one other, I guess, we have time probably for one more question. So what do you think is one of the big new developments? We've seen an explosion. Obviously, models are coming out at like, a new model every second. And it seems like that is not going to slow down. It may even accelerate, arguably, because of how enterprise is embracing open source models they can own and tune and serve efficiently. What do you think is one of the big areas where we're going to see some step change innovation? I guess evaluation again would be one, but like other than evaluation.
Yeah, I can give a different answer to this one to make it less boring. I think the three topics I've been most interested in my career. So we mentioned like retrieval augmentation, evaluation, and the other big topic that I've always been super interested in is multimodality. So my thesis was on multimodality and how that can lead to much richer understanding of the human world. And if systems really understand the human world better, they will be able to talk to us much more effectively as well. So natural language processing itself, it shouldn't really just focus on text. It should really focus on basically all the data that humans generate, because then you can really understand humans. And I think this trend is sort of starting right now. There's a lot of people jumping on the bandwagon, but there's a lot of amazing work from like 10 years ago where people were already doing very similar things. So it's fun to see this revival happening right now. But yeah, I expect a lot of big breakthroughs if they haven't already happened. I mean, GPT-4V is very impressive. So we're definitely getting there.
I think it's a great point. And I see we're at time. And now we're both getting kicked off stage because I think I've expended my max limit on the number of fireside chats. So Douwe, thank you so much for joining us. Really appreciate it. It was a great chat. I know I really enjoyed it, and it was great to see you.
Thank you.